Hello everyone. So this is another lesson in congruent triangle, proving congruence in triangles. Before I start, I would like to explain some certain vocabularies which are very vital to this lesson. Included angles. Now, what's an included angle? An included angle is an angle that is right between two sides that were marked. Take a look at side CB. You can see the marking there. And side AB. Now we need to put an angle right between these two marked sides, and that will be angle B. Angle B is now considered as an included angle. Take a look at the other triangle, side XY and side XZ. We need to put an angle right between these two sides, and that would be angle X. Angle X is considered as an included angle. So, included angle are angles between two sides. Take a look at these three examples. Let's start with triangle IGH. Where do you think an included angle can be located to be considered as an included angle? Angle G. How about the second one? We need to put the angle in the middle. Where would it be? Angle I. And the third triangle, where would be the included angle be at? Angle H. Also, we also have included side too. Included side is right between two angles, angle C and angle B. We need to find an included side that will be between these two angles. That will be side CB. So side CB is considered as an included side. And the other triangle, angle X and angle Z. Which side will be considered as an included side? That will be side XZ. Is a side that is between two marked angles. Let's try again. Which side will be considered an included side? The first triangle, that will be GI. The second triangle, that will be HI, high. And the third one would be GH. The next one we need to learn are vertical angles. Vertical angles are considered as opposite angles. Check out these two angles. They are considered or they are called vertical angles because they are opposite, right? They are the same. They are congruent. They hold the same value. And also, these two marked angles are considered vertical angles too. So the two angles are congruent. This included angle, included side, vertical angle is very important. We also need to learn reflective property. Imagine I draw a line and create two triangles. Can you see the two triangles? Let me label it A, B, C, D. You can see we have two triangles here, triangle ABC and triangle BBC. So they share a line. This line can also be called shared line segment. So these vocabularies you have learned will also help us to identify postulates that two triangles are congruent. So what are the postulates to prove two triangles are congruent? We have side, side, side. SSS postulate, side, angle, side. SAS, angle, side, angle. ASA, angle, angle, side. AAS, hypotenuse leg. This works with only right triangles. Ah, first of all, I need to remind you that they are postulates. They are not considered to be congruent. Angle, 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 and side, side, angle. Just remember, these postulates are not considered to make two triangles congruent. In case you forget, let's make an illustration here. This toy belongs to John, and this is Kate's toy. You see, they look alike, right? They are congruent. Adaming we swap the toys. Do you think John and Kate can identify their toys easily? No. So these toys look alike. These toys are congruent. How about we change John's toy to a smaller one? If you notice, the angle of the edges are equal to the angles of Kate's toy. However, John will notice there is a change in his toy size. So these two toys are not congruent. They don't look alike. So that concept is similar to this AAA. You cannot determine two triangles are congruent just because their angles are the same. And the second one, side-side angles postulates, SSA. How about swapping it to look like this? S. Nah, S don't work. S definitely don't work to prove two triangles are congruent. So let's start identifying the postulates. Side, side, side. Look at these two triangles. The three sides are congruent to the three sides of the other triangles. Side, angle, side. If you can notice, angle C in triangle ABC is an included angle, and angle Z in triangle XYZ is an included angle. Angle, side, angle. Side AB is an included side in triangle ABC, and side XY is an included side in triangle XYZ. Angle, angle, side. Please note that there is no included angle and included side in this one. However, this is still a proof that they are still congruent if you can prove two triangles have angle, angle, side. And the right triangle, hypotenuse leg. This is when you can prove that the hypotenuse of one triangle is congruent to the other triangle's hypotenuse and one of the leg. Then you can prove the two triangles are congruent. Let's take a look at these two questions and explain further. If you look, side AB is congruent to what side? Side DE. Side BC is congruent to what side? Side EF. Side AC is congruent to what side? DF. So we can say triangle ABC is congruent to triangle DEF using the postulate side, side, side. The next one. Take a look at these two triangles. Can you identify an included side and an included angle? Yes, we have an included angle here, angle A and angle D in the other triangle. So let's begin. Side ABC is congruent to what side? DE. Angle A is congruent to angle D. Side AC is congruent to side DF. We can say triangle ABC is corresponding to triangle DEF. So we'll say angle side is the postulate here. Take a look at this one. We have an included side too. So we'll say angle A is congruent to angle D. Side AB is congruent to side DE. Angle B is congruent to angle E. So therefore, triangle ABC is congruent to triangle DEF using the postulate angle side angle. And this one. Alright, can you see this two triangle? It doesn't have an included side or included angle. But that doesn't matter. You can still find or prove that these two triangles are congruent using another postulate. So let's take a look at it again. Angle A is congruent to what angle? Angle D. Angle B is congruent to angle E. Side BC is congruent to side EF. Therefore, triangle ABC is congruent to triangle DEF. Angle, angle, side. And they have two right triangles. They have two right triangles. Here is the hypotenuse in triangle ABC congruent to the hypotenuse in DEF? Yes. Is one of the leg congruent to the other leg in the other triangle? Yes. Is it a right triangle? Yes. So, this is a right triangle, right? Let us solve this problem here. What do you think would be the postulate for this? Is this congruent, by the way? Three angles are the same, AAA. So, no, AAA is not considered as a postulate to prove two triangles are congruent. How about these two triangles here? We have side, angle, side. And the angle is an included angle. We have side, angle, side, an included angle. So we will say SAS. Yes, they are congruent. How about this one? We have angle, side, angle. The side is an included side. We also have angle, side, angle. And this side is an included side. So we could say ASA. Now, this is some special triangle here because we have a reflective property here, a shared line segment. So down here, down here, we have these two sides congruent to each other, and the angle, it looks like it's an included angle and a side. So we have SAS. Let's take a look at this question. Now, what postulates does this follow? If you notice, we can identify these two angles as vertical angles. So this will help us determine what postulate we're to find. Now take a look at it again. Side, angle, side. That will be the answer. Take a look at this question too. Isn't it a right triangle? Yes, they are right triangles. We should ask ourselves, is the hypotenuse, are they congruent to each other? And the answer is yes. The two hypotenuse are congruent to each other. Then pick a side or the legs. Is any leg congruent to the other side of the other triangle? Yes. So this is a right triangle with a hypotenuse congruent to the other triangle and a leg congruent to the other triangle. So we can consider this Don't forget to subscribe to this channel if you happen to get more information. Goodbye. See you next time. Bye.